Hey there, phenomenal future nurses. Welcome to the first step of our exciting adventure, a journey through the incredible world of anatomy and physiology. I'm your guide on this ride, and I'm thrilled to be here with each and every one of you. Now, I know this might be a bit new for some of us, but trust me, by the end of this journey, you'll be amazed at the wonders your body holds. We're going to explore the beauty of how everything works together, from the tiniest building blocks to the grand symphony of organs and systems. So, whether you're here with a sparkle in your eye or a bit unsure, know that we're all in this together. No question is too small, and every discovery is a win. So, buckle up, get ready to dive deep, and let the adventure begin. Are you ready? Let's do this. Matter is defined as anything in nature that occupies space and mass. Most structures in the body we will discuss will not be able to be seen with the naked eye. Even though they are microscopic in nature, they still have mass and occupy space. Throughout the course, it is necessary to learn terminology that is specific to anatomy and physiology. Our first term is mass. Mass is an object with weight and shape. Within the human body, there are many things that we cannot see with the naked eye. We must realize that all of the structures inside of our bodies occupy space and have a shape. From the largest to the smallest, all things in the body. We will see how the shape of a structure is directly related to its function. There is a saying in physiology: form follows function. The smallest unit of matter is an atom. Atoms cannot be seen with the naked eye. They are microscopic. And there are billions of them in our bodies. Inside of every atom in the center is a nucleus. The nucleus contains protons and neutrons. The proton always will have a positive charge. The neutron will have a neutral charge or no charge. Remember, protons have a positive charge. Neutrons are neutral and have no charge. The nucleus is always positive. The atomic number of an atom is equal to the number of protons in the nucleus. Now let's test your understanding of what we've talked about so far. Which of the following best defines matter? An atom is defined as. Please select all that apply. Atoms' shells or orbits surround the nucleus. Electrons occupy those shells. Electrons are floating around the nucleus, whereas protons and neutrons are inside of the nucleus. If all the orbits are complete, the electrons in orbits will equal the protons in the nucleus. The atom will have a zero charge. The electrons that circle the nucleus are very similar to the planets that circle the sun. The orbits are specifically arranged. The first shell or orbit closest to the nucleus has 2 electrons. Remaining shells around the nucleus have 8 electrons in each shell. She has outermost farthest from the nucleus, may not have a complete 8 electrons. These shells will be considered unstable. Electrons in unstable shells are looking to bond with other unstable shells from other atoms. The ultimate goal is to have a complete outer shell with 8 electrons, thereby being stable. Atoms are attracted to each other because they want to achieve a stable outer electron shell. The diagram shows how oxygen and hydrogen bond together and share the most outer shell of the oxygen molecule to form a stable H2O molecule. The oxygen molecule needs 2 electrons. 2 hydrogen molecules bond to the outer shells of the oxygen to provide it with 2 additional electrons. Now the H2O molecule is stable. Let's test your understanding. How many electrons are in the balanced shells of an atom? What does an unstable electron do to become stable? Please select all that apply. Now we're going to discuss atom bonds. The first type of bond is called ionic bonding. Electrons are transferred from the outer shell of one atom to the outer shell of another atom. Covalent bonds are when the outer shell of two atoms share the same electron. The diagram is showing how atom A and atom B both need an outer shell electron, and they end up sharing it together. That is called a covalent bond. A hydrogen bond pertains to the hydrogen atom. For instance, the hydrogen atom attracted the oxygen atom, forming the water molecule H2O. There are two hydrogen atoms bonded with one oxygen atom. This specific hydrogen bond is considered to have polarity. Polarity is what causes water molecules to attract to other molecules, which makes water an excellent solvent. Substances easily dissolve in water. Water is considered to be the universal solvent because of a polarity. Let's test your understanding. What type of bond is polar? What is an ionic bond? The term element refers to matter composed of atoms that have the same number of positive charges in their nuclei or their protons. In other words, if two or more substances have the same number of protons in the nucleus, we consider those to be like elements. All matter, living or dead, is composed of elements. Organic elements are molecules that contain the carbon atom. You will find that all organic or living matter will contain the carbon atom. This is where the term organic chemistry comes from. Here are some of the essential common elements in the body with the periodic symbol: oxygen O, carbon C, hydrogen H, sodium Na, potassium K, calcium Ca, phosphorus P, nitrogen N, iron Fe, chlorine Cl. Few more definitions. These definitions refer to the different formations of elements. A molecule, two or more atoms that have bonded together or attached to each other. They can be the same atoms or different atoms. A compound, molecules formed by two or more different atoms. A chemical, two or more substances. A substance, matter that has uniform properties or the same characteristics. Example: an apple is made of multiple chemicals. All apples have uniform properties. We call those properties an apple. The body is made up of chemical substances. The chemicals in our body go through reactions. Chemical reactions. The food we eat, the water we drink, the air we breathe are all chemical substances. We digest our food, move our bodies, experience emotions and think great thoughts because of chemical reactions. In physiology, we discuss chemical reactions and how they function in the body and allow the body to maintain its status. Let's revisit water. Water is essential to life. It is the most plentiful element in our body. It is called the universal solvent. Water is a compound able to dissolve many substances in the body. It is polar and is considered essential to life. Time to test your understanding. What defines an element? Please select all that apply. Name 3 essential elements in the body. Why is water considered the universal solvent? Now we are going to talk about electrolytes. Electrolytes form ions when dissolved in water. Ions are either cations or anions. Electrolytes are substances or chemicals that form ions when dissolved in water. Atoms with an electrical charge are called an ion. Ions have a negative or positive charge. Positive ions, have a positive charge electrolytes whose outer shell has lost an electron, meaning there are more protons in the nucleus than electrons in the outermost shell. These are called cations. Negative ions have a negative charge. The outer shells have more electrons than protons in the nucleus. These are called anions. Cations that we use a lot in the body. Positively charged ions such as sodium, potassium, hydrogen and calcium. An anion that we use a lot in the body is chloride. When atoms are electrically charged or ions, they are able to conduct electrical currents in the body. They produce electricity. Let's test your understanding. How is an ion formed? Please select the most comprehensive definition. Test your understanding. What type of current is conducted with ions formed by electrolytes? There are different forms of energy in the body. Chemical energy, made by the reactions of chemicals. Mechanical energy, made by the movement of structures in the body. Electrical energy, energy released from the movement of charged particles. Thermal energy, made in the body to control body temperature. The main energy made in the body is chemical energy. This comes from the food we eat. Nutrients are absorbed as elements and substances from food. Energy is then made inside of the cells, or cellular energy. And this cellular energy is made by adenosine triphosphate or ATP. It is made in the mitochondria of the human cell. ATP is the molecule that is required to transfer energy from the food that we eat. The energy of ATP or adenosine triphosphate is made from high-energy phosphate chemical bonds. Here is a diagram of an ATP molecule. Please notice the three phosphate molecules that each are bonded together. These bonds are considered high energy. When these bonds are broken, large amounts of energy are released. Test your understanding. What type energy is used in the body? Please select all that apply. What bonds are broken to release the energy of ATP? Acids and bases. An acid is an electrolyte that splits into a hydrogen ion, a positive hydrogen ion and some negative anion. A base is an electrolyte that can neutralize the acid by reacting with a positive hydrogen bond. The scale that determines if a substance is an acid or base is called the pH scale. How much acid or base is determined by the number on the pH scale. A pH of 7.0 is neutral. Water is neutral, so water has a pH of 7.0. An acid, acidic, or something that is acidic has a pH of less than 7.35. A pH of greater than 7.45 is considered an basic or alkalotic or alkalosis or alkaline. Note the prefix, alka. Blood should be in a range of pH of 7.35 to 7.45. Blood is alkaline. A pH less than 6.8 or higher than 7.8 is considered to be fatal. Please see the diagram of a pH scale. Notice that the acid end, lower numbers, are at the top of the scale, acidic. And the larger numbers, the basic end, is at the bottom with neutral in the center. Acid-base balance. This is a very important principle in the body. The normal function of nearly all physiological processes in the body depends on the maintenance of the appropriate acid-base balance. Electrolytes play a role in maintaining the balance between acid and base. Electrolytes in the body are classified as acid or base. Acid-base balance is regulated by two systems in the body. The urinary system, where kidneys control acid-base balance with urine excretion. and the respiratory system, where lungs control acid-base balance with exhalation. Some terminology to remember. Acidosis is a condition with a pH below 7.35. Alkalosis or alkaline is a condition where pH is above 7.45. We draw blood gas. A test from blood to determine the pH of blood and make a decision if something is within range acidotic or alkalotic. Let's test your understanding. Here is a scenario. A patient is admitted for respiratory distress and poor oxygenation. The respiratory therapist has drawn blood gases to determine his true respiratory status. The results indicate that the patient is in respiratory alkalosis. The nurse expects that the results will show a pH of. Let's test your understanding. Which organ systems are responsible for regulating acid-base balance? Please select all that apply. Mixtures and solutions. A little more terminology here. A mixture is where two or more substances put together physically without a chemical reaction. A solution is a mixture, but the particles remain evenly distributed. And there are two parts. A solute, which is the smaller substance in the solution, and the solvent, which is the larger substance in the solution. The solvent does the work of dissolving the solution. Can be gas or liquid. An example of a solution would be salt water, where salt is the solute and water is the solvent. We also have suspensions. Suspensions are mixtures, but the particles are very large, and they tend to settle at the bottom. And the mixture needs to be continuously shaken in order for them to mix. Precipitates. In a precipitate, a chemical reaction forms a solid in the solution. What is the definition of a solvent?